You know the scene, right? We've all seen it in movies a million times. The captain gives the order, the ship's engines roar to life, and bam, the stars stretch into these brilliant lines of light. It's the ultimate science fiction dream, interstellar travel in the blink of an eye. But what would happen if we tried that with a real rocket? Say, the most advanced one we've got.
So let's ask the big question. Could SpaceX's Starship, if we gave it some crazy futuristic engine, just keep on accelerating until it hit that ultimate cosmic speed limit?
I mean, the idea seems so simple, doesn't it? You just keep the engines firing. More push means more speed. You point your ship at a faraway star and just floor it, accelerating and accelerating until you hit that magic number, the speed of light. But, and this is a big but, this is where physics slams on the brakes. The universe doesn't just politely say no to this dream. It has fundamental laws that create this violent, absolutely destructive barrier. It's not just impossible, it's self-destructively impossible. And to really get why, we have to talk about the man himself, Albert Einstein, and his incredible theory of special relativity. Because he's the one who figured out that c, the speed of light, isn't just some random number on a speedometer. Nope, it's woven into the very fabric of the universe. So here's the core rule, the big one. Special relativity proves that nothing with mass, and that means you, me, a planet, or even a massive rocket like Starship, can ever reach the speed of light. It's not an engineering challenge we'll solve one day, it's a fundamental rule of existence. You can almost think of it like this. The universe has its own set of unbreakable fail-safes to protect this one speed limit. It's got these built-in rules that just won't let you do it. And the first one? Well, the first one is a real heavyweight. It's all about weight. Now, this is where things get a little weird, but stick with me. Imagine you're pushing a shopping cart. Easy at first, right? But what if the faster you pushed it, the heavier it actually felt? That's exactly what happens to Starship as it gets closer and closer to the speed of light. This mind-bending concept is called relativistic mass. And to be clear, the ship isn't actually gaining more atoms or getting physically bigger. What's happening is its inertia, its resistance to being pushed, goes through the roof. The universe itself starts pushing back, making it harder and harder and harder to go any faster. Just look at these numbers. It's insane. At half the speed of light, Starship feels about 15% heavier. Manageable. But get to 99% and it feels 7 times heavier. And at 99.99%, it's like trying to push a rocket that weighs 70 times its original mass. The energy you'd need becomes just astronomical. So, what does it take to get that last little fraction of a percent to finally hit 100% light speed? The answer is an infinite amount of energy. It's literally impossible. The ship's relativistic mass becomes infinite. You could harness all the energy in the entire known universe, and it still wouldn't be enough for that final push. Game over. But let's just pretend for a second. Let's say we had a magic, infinite energy source. Problem solved, right? Wrong. Even if we could somehow overcome the mass problem, Starship still wouldn't make it. Because the next barrier isn't about pushing forward, it's about sheer survival. You know, we think of space as being completely empty, a perfect vacuum. But it's not really. It's filled with stray particles, mostly tiny little hydrogen atoms. Now, at the speeds we travel today, they're totally harmless. But at near light speed, every single one of those insignificant atoms turns into a microscopic bomb. Think about it this way. You are flying directly into a cosmic shotgun blast. At 99.9% the speed of light, every hydrogen atom smacks into your ship with the energy of a particle fired from a high-energy accelerator. And it's not just one. It's a constant, relentless bombardment. The result would be absolutely catastrophic. First, the intense radiation from these impacts would be lethal to anyone inside instantly. Then, the ship's heat shield would just vaporize. After that, the steel hull itself would be ablated, literally sandblasted away, atom by atom, turning into a trail of superheated plasma. So let's recap. We have two completely insurmountable universal fail-safes, an infinite energy requirement, and a cosmic firing squad made of hydrogen atoms. The universe is making its rules very, very clear on this one. And really, this is the main thing to remember. The speed of light isn't some kind of record we're trying to break, like the 4-minute mile. It's a fundamental wall. It's a boundary built into the fabric of space-time, and the universe has some incredibly violent ways of making sure you don't even get close to touching it.
So for any object with mass, like Starship, like us, the answer is a definite, hard no. It's just not going to happen. But that does raise a really fascinating question, doesn't it? If we can't break the rules of physics, maybe, just maybe, we can find a way to bend them.